In both our applications, we're going to use a high volume oil pump. Please do not confuse this with a high volume, high pressure oil pump. A high pressure oil pump is not necessary for our applications. And with proper bearing clearances, a high volume pump by itself will give you approximately 60 pounds of hot at-speed oil pressure, which is more than adequate. Also, with a new oil pump, just because it comes in a neat, clean little plastic bag, never assume that it's free of defects or debris. Always open a new oil pump, clean it, and inspect it. We're going to go a little further than just inspecting it, though. We are going to improve our pump. If you please take a look at the inside of the main cavity of the pump body, first what we will do is take a scraper or a small file, and we're going to completely deburr this whole perimeter. All we need to do here is break the edges. We don't have to go any further than that. Also, these large, long vertical lines on the edge of the machine chamber and the cast finish area should also be deburred, as on this side. Down at the bottom of the pump, you notice converging lines between finished areas and cast areas also must be smoothed out. Once we've broken the edge with a scraper or file, we should take a 300 to a 320 grit emery paper on our finger and lightly polish these areas to ensure that they're smooth. On the outside of the main pump body, we also want to do the same treatment to the output cavity, the bolt hole area, down through the discharge cavity, also where the main pump shaft exits the pump body should be chamfered. The oil pump cover plate should also be given the same treatment in all internal areas. And in case where the oil pump pickup tube goes in doesn't have a nice radius, that should also be chamfered. Next, we want to check that our relief valve is free. That's this little piece in here. By taking a sharp object, we should be able to easily push this valve down and have it return. Ours does. Later, when we go to install our pickup tube and full weld it into position, we're going to have to remove this oil pump relief valve and the spring behind it. To do that, we'll look at this small hole in this area. In that small hole is a locking pin. By taking a small drift, we can knock this pin out, going from the bottom of the housing up to the top, because this pin does have a taper, and remove the spring and the shuttle inside. We'll go into this a little further when it comes time to weld our pickup in place. Now let's turn our attention to the two rotors inside the oil pump. What we first want to do is lightly deburr all the edges on both ends of both gears around each lobe. Once again, we're not looking to remove a lot of material, just break the edges and lightly polish them with emery. This is the idler gear, and we're going to drill 3 holes in this to assure that we get proper oiling to the shaft that it rides on. To do that, we take a 1/16 inch drill bit. We're going to drill 1 hole in the center of the length, going directly perpendicular to the shaft that it rides on. In essence, this hole is going directly through this way. It doesn't go all the way through to the other side, just to the inside dimension here. We'll turn our rotor 2 teeth, and now we're going to drill a hole at one end. We'll turn another 2 teeth and drill a hole at the other end. When the 2 rotors come together, they compress the oil between them. Some of this oil now is going to be pushed through that hole, and it'll give us positive oiling on the idler shaft, ensuring us that it won't seize or gall. Before closing up the oil pump, it is imperative to check the clearance on the end of the rotors. We're speaking about the clearance between the face of the end of the rotors and the parting face of the pump body. To do this accurately, we need a depth mic. Very simply, we're going to position the depth mic across the pump housing and make sure that the center part of it is touching on one of the lobes of the rotor. We're going to take several checks in different areas because this clearance can vary. It's all right if it varies as long as all the measurements are between 1 and 3 thousandths. We turn the mic down gently just till it contacts the pump rotor. And checking this one, our clearance here is 2 1/4 thousandths. In this area, it's fine. As I mentioned, though, we're going to take several checks because this distance can vary between machining tolerances. In this area, we have only 2 thousandths, but it's still okay. In the event that your clearances are not within tolerances, they can be adjusted very easily. Let's say, for example, we have too much clearance. This can be adjusted by removing the rotors, placing a sheet of 200 or 220 grit sandpaper on a flat surface such as a surface plate, placing the housing on it, and gradually sand the housing down, continually turning it to make sure that we take it down evenly. This is an effective way to reduce the height of the housing and restore our pump clearance. If the fact is that you have not enough clearance, you can do the same procedure but on the pump rotors. Once again, working carefully and continually turning the piece, you can accurately and evenly reduce the length of the rotor, therefore increasing your clearance to the desired specifications.